Welcome viewers. In this video we'll discuss the dynamic characteristics of a stepper motor. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic, dynamic characteristics of stepper motor. What is dynamic characteristics? The characteristics relating to the stepper motor which are in motion or about to start are called dynamic characteristics. So under running condition, during the running condition are going to start. So under stable condition is called a static characteristics. Separate video available for static characteristics. Here we are discussing dynamic characteristics. The curve drawn between the torque and the step rate gives the dynamic characteristics. Right, so this curve is drawn between torque and step angle. Now we'll see the diagram. I will see the dynamic characteristics, then we'll go for the different parameters. So this is the dynamic characteristic. So this x-axis we have step rate, that is the stepping angle. In y-axis is the torque. Torque is available. So there are two curves available. Pull out range. There are two curves available. This is a torque point. This is a maximum starting torque. So at that there are two curves are available. This first curve refers the pull in curve. Second curve is refers pull out curve. We see what is pull in, what is pull out later. So the x-axis what we have step angle, y-axis stepping rate in frequency, in terms of frequency, stepping rate and torque. So this point is called a maximum starting torque. This is holding torque. At that we have two different curves available. The first curve is pull in curve, second one is pull out curve. So based on that there are three regions available. Then is pull in range. This region is pull in range. This is slew range. This is pull out range. So this curve where it starts, where it cuts is called a maximum starting frequency. Right? So this is maximum starting torque. This is maximum starting frequency. Then we have unrotatable range and stable range, two parameters also available. The second curve, pull out curve, where it cuts the x-axis is called a maximum slewing frequency. Right? So this point is maximum starting torque. First curve where it cuts is called a maximum starting frequency, and second curve where it cuts the x-axis is called maximum slewing frequency. Right? This is pull in curve, pull out curve. Pull in range, pull out range, slew range. Now we'll see these parameters one by one, how it is behaves. So initially the torque is more, when the step rate is increases, it keep on decreases. Both are keep on decreases, but the range is different. Where it cuts is the different points. Now we'll see the terms one by one. So first we will see pull in torque curve. What is that? It is called starting characteristics, and it is a range of frictional load torque at which the motor can start and stop without losing the steps for various frequency in a pulse train. So pull in, the meaning itself, pull in means we can start and stop without losing the steps. Right? There is no control, the is fully under control. In this range, fully under control, so that we can start and stop the motor without losing the step for a various frequency range of pulse train. That's why it is called a pull in torque curve. Then pull out torque curve, it is completely opposite, pull out torque curve. It is called slewing characteristics. After the motor is started, by giving the specific excitation, the pulse frequency is gradually increased, and during this increase in frequency the motor has to synchronize with the pulses. So while giving the pulses, gradually we are increasing, so this frequency should synchronize with the pulses. During the increase in frequency, the motor to synchronize. The relation between frictional load torque and maximum pulse rate at which the motor can synchronize is called pull out curve. So under the control is pull in torque, pull out curve means it is under that it is synchronized, fully synchronized. The pull out curve is greatly affected by the driver circuit, coupling, measuring devices and other conditions. So due to this it may going out of range. That is the driver circuit, coupling, measuring devices and other condition will may affect. So pull in torque means fully controlled, can start and stop without losing. Pull out torque means it is synchronized. The torque and this frequency range is synchronized, but it may affect by different parameter called driver circuit or coupling, measuring devices and other conditions. Now we'll see the other two parameters. So the next parameter is maximum starting frequency. So it is defined as maximum control frequency at which the unloaded motor can start and stop without losing the step. So it is corresponding to the pull-in torque. Pull-in torque curve where it cuts the x-axis, that frequency is maximum starting frequency. So there is no without losing the step. So what we discussed same in the pull-in curve, right? Is the motor can stop and start without losing the step. The corresponding frequency is maximum starting frequency. The corresponding torque is called a maximum torque. That curve is called pull-in curve. Then maximum pull out rate or maximum slewing frequency. So this is refers the second curve, pull out curve, where it cuts the x-axis. It is defined as maximum frequency at which the unloaded motor can run without losing step. This is a loaded, unloaded motor. Unloaded motor can run without losing the steps, right? So this is control at which the loaded motor, unloaded motor can start and stop, right? This is running, it's under running condition. It is loaded can run, right? And one more parameter is available, maximum starting torque. So that is the point available at the x-axis, y-axis. From that only these two curves are available, pull-in curve and pull-out curve. So what is that maximum starting torque? The name itself is clear. It is also called maximum pull-out torque and is defined as the maximum frictional load torque with which the motor can start and synchronize with the pulse of train with a pulse train of frequency as low as 10 Hz. Right? So this is a maximum starting torque. This is a corresponding frequency. It is defined as frictional torque. Synchronize. The motor can start and synchronize with the pulse of train. Even the frequency is about this 10 Hz. Right? So it is running condition. This is corresponding to the second curve, pull-out torque. Right? So it is synchronized. The first one is it is start and stop. This is synchronized even at the low frequency of 10 Hz. So in this video we discuss dynamic characteristics of a stepper motor. The two different curve available, pull in and pull out, based on the three region, pull in region, pull out region, slew region. Then the torque corresponding is maximum torque, maximum starting torque. Similarly in the x-axis what we have is maximum starting frequency and maximum slewing frequency. This all parameter we discussed one by one. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. All the best for your examination. Thank you for watching.